Alright, hello, welcome back to A Software Engineer Plays, the channel where a software engineer, that's me, plays through games designed to teach you programming skills and logic. We are still in Human Resource Machine. Last time we were looking at the littlest number in the cumulative countdown levels, finishing off with the coffee break where we saw that the world is getting taken over by robots. So that's fun. So let's go ahead and jump into the storage floor here, level 29. See what we got. Big changes are coming, but I see you already know that. Yes, you can now access slots on the floor indirectly. What does that mean? You will see. It's going to change everything. Okay. Imagine each thing in the inbox is an address, and the address refers to a tile 0 through 9 on the floor. Your task for each address in the inbox: pick up the letter at that address and outbox it. Okay, so that's cool. So basically what this is saying, if I'm reading it correctly, is instead of treating this 9 as just a number 9, we can now use it to access slot 9 on the floor. So basically, it looks like it's going to want us to pick up the letter from each of these slots. So we'll pick up 9, then we want to outbox a J, we'll pick up 5, we want to outbox a D, 8 will be Y, 3 is E, and 5 is D. So let's... we're gonna want to inbox. That much is pretty obvious. And then we're gonna want to store in 12, I think. Yeah, so we do want to store it. So copy 2 here, and then copy from 12 indirectly and outbox. And then jump. So this should store 9 here, and then we will copy from... That's nice, it draws a little arrow to show you what it's doing there. Okay. This is looking good. That's cool. Alright. Alright, so it's a pretty simple example just to get us into using the indirect commands. So that was pretty cool. So let's go ahead and jump into the string storage floor now that we know about that indirect command. Special covert assignment. Management is requesting strings from the floor. Let's just process the strings and not read or discuss what they say. Okay. And forbidden. So it would be impolite to read these messages and forbidden, so no one read these messages, please. Each thing in the inbox is the address of a tile on the floor. For each address provided in the inbox, outbox the requested item from the floor and all following items on the floor until you reach a 0. Okay. So, if I'm reading this correctly, we will take 4, and then we'll start at index 4 and keep outboxing the next memory address, so 4 or 5, until we hit a 0. So obviously we are going to need to inbox, and I want to then store that in 24. Okay, so now we want to copy from 24, but indirectly, and then move to the outbox. Then we want to bump up 24. And now this is going to be the thing, is that every time we copy, or every time we bump up rather copy from, excuse me, we want to jump if it's 0. So if it's 0, we need to go back to the inbox and start all over again. Otherwise, we keep on going. Okay, so I think this will work. We inbox, get a 4, we store it there. Then we're going to go to memory address 4 because of the indirect. Put that to the outbox. Then we're going to increase this to 5. We're going to get 5, move it out. It's not 0. Then we're going to bump up the 5 to a 6. And then we're going to go to 6. It's going to be 0. So we will then start again. So let's see that happen here. Put the 4 there. Copy indirect. Out goes the T. Bump that up to 5. Copy indirect. Out goes the H. Bump that up to 6. So we go to 6. It's a 0, so we start again. Looking good. So the whole, the concept of accessing things indirectly is somewhat similar to the concept of pointers in programming. The way pointers work is that they're basically just a reference to a place in memory. And they're pretty complicated to try and explain just in talking to you like this while our little guy does his work. But there are some languages like C++ where you have to use what is called a pointer to do dynamic allocation of memory, which is it's required for writing your own data structures and a lot of other slightly more complicated things when it comes to programming. A lot of other languages like Java and C#, you don't actually have to declare pointers. So a lot of those languages, everything is already treated as a pointer behind the scenes, which makes life a little bit easier for the programmer. Because pointers get complicated and you have to keep track of a lot of stuff that's going on in memory when you have to declare the pointers yourself. Anyway, this guy's working along quickly. Speed him up just so we can get this completed and see if we have any optimization to do. How did we do? We did it in 7, and we did it in 203. Perfect. Alrighty, so let's jump then into the string reverse. So I think we're probably going to Hola. Ya datui irawa. Aha. Haha, okay, now seriously. Okay. So we are going to, we have 0 terminated strings here, so once we reach a 0, we'll know we're at the end. So basically, I think what we're going to do here is every number we pick up, we're going to store indirectly in the memory address here and use this as our counter, and then we're going to use that then to count back down to reverse the strings. So hopefully that makes sense. We want to copy this indirectly to what's stored in 14, and then bump up 14 until we hit a 0. Then once we hit 0, we are going to, and this is really cool, since we've counted up the number of letters, we know now that whatever is stored in 14 we want to copy from indirect, and then outbox it and bump down 14. And we want to do this, and then we want to do this until 14 is 0, at which point we jump back up to the top. So you can see having the indirect, the ability to reference things indirectly, is making it kind of nice for us, because in previous programs we would have to say move to 0, copy to 0, copy to 1, copy to 2, copy to 3, so on and so forth. But now, because we have this counter variable down here, we can just expand our memory dynamically, essentially. So let's see if this is working as I expect it to. We're going to inbox, and we're going to copy it to what's stored in 14, that memory slot. So we're going to store it in 0. And then I have selected the wrong square to bump there, my bad. But we got to see a funny little message about bumping a letter that doesn't make a whole lot of sense. Coincidentally, in some programming languages you can actually add numbers to letters, because in programming and in computers, a letter is just a number behind the scenes. So there's this thing called the ASCII table. And the ASCII table basically defines how a computer will interpret an 8-bit string as a number. Okay, so we've got a problem here now, and that problem is we're going one too far, basically. So let's see that again here. So we put it in 1, and then we put that there. We bump up, and now we get this here. And so now the problem is we're moving 1 too far forward, basically. And I think, let's see, how can we get around doing that? Basically, we want to start it. Well, we don't have to start at 0, but we want to start at 0. Well, for the time being, I'm just going to put a bump down in the middle there. And then we can see if there's something we can do to make it a little bit nicer. Okay, so the reverse seems to be working as expected. And we may be able to put like another inbox in here to get around this extra bump down command. But oh, that's interesting. So we have actually, we're missing something on the other side too. Because, oh, hey, that's what we can do. We'll put the bump down before the outbox. And that way we'll see it happen here. We'll get to the end of the word. Okay, so now we're going to pick up a 0 and we're going to jump down. So now it's at 5. And we actually want to move the copy from down there as well. Okay, so starting again, we get the word out, step in here. Okay, so now we have bumped up to 4 because that will be the next spot, but we pick up a 0, so we're gonna move down here, bump down to a 3, so then we're gonna copy from 3 outbox, and I realize now that we need to check to see what's in memory register 14 there. So I mean, it's not great to put the put a copy from there, but it seems to be working. It's probably already this. So let's see. Okay, we did it in 11, and we did it in 118 steps. Okay, so I guess that extra picking up of what was stored in register 14 wasn't a step too far, so that's good to know. So that's string reverse done, and now let's see what the inventory report's all about here. Level 32. Inventory check. Accounting verification, surprise audit. These are a few of my favorite things, so let's get started. For each thing in the inbox, send to the outbox the total number of matching items on the floor. Okay, so we have a 0. How are we going to see if we can't subtract letters, can we? For each thing in the inbox, sent to the outbox the total number of... Okay. Does that make sense? Sent to the outbox the total number of matching items on the floor. So B would be 1, 2, 3, 4, 5. Okay. So we can subtract letters, which is kind of funny since they told us that we couldn't bump one last level. I guess we can do some math with the letters, but not others, but it is what it is. Okay, let's set up our loop to go through these. So we're going to call this our counter. Counter. Okay, so we want to, first of all, we inbox. I'm going to store that in number 15 here. We're going to call that our compare. Okay, and this will be our result. So first of all, we want to copy. Okay, so I think what we want to do is make a copy of 0, a copy from the counter, and copy it to the result. So we have 0 down here. So now we're going to inbox and store and compare. So now we can start our loop. So we are going to copy from indirect counter, subtract, compare, and if the result is 0, we want to bump up our result. Otherwise, we want to... Well, either way, we want to bump up the counter and then loop. So jump up to there. Okay. So this should work until we hit 0. So if it's 0, then we can start again. But we also, obviously, we want to copy from the result and outbox that. So let's just jump in there. So, okay, so we're going to jump here, we're going to initialize our result. Okay, so far so good. Then we're going to get our number to compare, or letter to compare. Okay, so now we're going to pick that up, and it's not 0, so we're going to subtract our compare, get a 0. Now because it's 0, okay, I've got this backwards. So because it's 0, we want to bump our result. Otherwise, man. No, that doesn't work. We want to bump our counter either way. If it's 0, we want to bump our... Man, okay. So we will... Can we bump our counter a little bit earlier? And then jump up there. Okay. Okay. Okay, what happened there? Okay. Oh well, I guess we'll just do this twice. And we may be able to make that a little bit better, but for now, I think it's the only way we can get this working. At least it's the only way I can think of right now. So now we're stepping through here, and that's gonna not be 0, so we're gonna move up our counter, and then keep on going. Okay. Good deal. Let's just keep on going here. B. Okay, so now we're gonna get a C, and it is 0, so we're gonna move down here, bump up our result, and bump up the counter, and then continue. Okay, good. So that's all working. Oh. Okay, oh boy. But because our counter, we're adding to our counter as well. We need another counter. So we'll call this null. We'll call this counter. So copy from null to... I think I can copy to counter as well. Okay. Copy from counter, bump plus counter, bump plus counter. Okay. So now we've got... now we've got everything set up. Yes, that's it. Okay, so... I want to choose something else. Hooray! How do we do? Okay, over by 1. Good on the speed. So let's see where we can pare down here. I'm thinking it's gotta be down in here somewhere. So once that's 0, that has to be there. Once it's 0, I think it's gotta be this part down here. So sub compare. Then if it is 0, we want to we want to bump the result. Then we can jump back in and we can bump up the counter. There we go. Okay, so just a little bit more jump trickery going on in there. So if it is 0, we bump up the result and then jump back in instead of having those multiple bump ups of the counter. Now I have to sit and watch this happen again, which is not fast, but it's fun to watch him dance around like that. Kind of an interesting way to show the way that some strings, especially in languages like C, a string is literally an array of characters just like this. So you could do this exact problem just like this in C. Step through the array. You can even subtract the letters from each other to determine if they are the same character. So this problem, you could do it exactly like this in C. Except you wouldn't be using jump statements, you'd be using for loops. So that's pretty cool. Anyway, we've now turned on both lights here, so let's go to the elevator and find out where Carol is. Where is Carol?
Hey, where's Carol?
I don't know. Uh-oh. Oh, Carol, oh no. Oh no, Carol.
This coffee is amazing. Back to work, ladies.
Oh, wow. That's sad. Poor Carol.
Breaking. Previous reports of machine army evaluate to false. Everything equals 100% fine. Whether within pleasant tolerance parameters
Oh,
or
good,
human
okay.
skin layer, you're all going to be fine.
Oh, Mel. Poor Carol. Pour one out for Carol. Anyway, thank you very much for watching. This has been A Software Engineer Plays. I hope you enjoyed the video. If you did enjoy it, please consider liking and subscribing. And we'll be back next time to look at the vowel incinerator, which promises to be very exciting. Anyway, I hope you have a wonderful day. Thanks again for watching. Bye.